Hey guys, in this video we're going to be talking about third dimension fun with PVFARM, or how to move from no idea to some idea, educated guess and actionable insights when designing solar PV projects with PVFARM. Okay, so let's get started. I'm prepared a very small project which basically have a simple block, I would say a bunch of trackers with combiners, central inverter and transformer. Okay, it's flat, so it's flying, and then we have substation, terrain, boundaries. So let's say this is usually a starting point. The solar project, people usually design it from this starting point. You basically have a flat layout and you just try to understand what kind of shading, what kind of energy, what kind of cut and fill, grading considerations and stuff like that. Okay, so what we can say about flat layout? So first of all, we can definitely go and actually understand approximately the energy production, right? We probably can go even further. I mean, meaning we know module, we know the position, location of the project, we know the meteor data and all this stuff. I'm kind of assuming we do understand this, but basically what else can we actually get from this data? So first of all, we probably can also go and calculate shading, right? So I'll basically calculate shading based on the flat layout. So you can see here we just basically lose 11.98% of energy simply because we have a trackers kind of positioned close to each other, right? So that's pretty much it. So we can have some idea about shading, but we have no idea about terrain, we have no idea about cut and fill, we have no idea whether we want to use rigid or terrain following trackers, and also we have no idea whether we will have the same shading loss, right, when we will just place the trackers on the terrain. So let's probably start from here, okay? So now we have terrain, okay? And basically we want to understand when those trackers are placed on the terrain, how different the shading will be, right? So let's go here. I'll just basically select all our trackers and then I'll just ignore the terrain, actually cut and fill. I will allow, any angle for the slope for the tracker, and I'll just place those trackers on the terrain, okay, as they are. If you'll get closer, you can see that basically we place them as they are without any optimization, without any cut and fill, without anything like that, right? So if I'll show you the cross section, you'll see some crazy kind of situation here, but basically that's kind of I would say simulation of how those trackers can be placed on the terrain. Here obviously we can always check whether it's possible or not, right? And so there are two different angles from which you can actually check whether it is possible. So the first one, you probably have some manufacturer specification, and let's say if I'll go to my trackers, let me just choose my tracker, and then I will basically choose the property which is slope, let's say first to last, okay? So then we can colorize our trackers, and then basically we can see, okay, so everything above 10, this is where we have problems, right? So that's kind of analysis we can do. We can also do a piles analysis. So basically if we set up the pile reveal and embedment 4 feet and 4 feet, so basically all the piles above 8 feet plus minus some 1 feet or maybe 2 feet, basically will potentially a problem for us, right? So but now let's basically go back and start from here. So first of all, we will not analyze trackers here, but we want to understand how did it affect the energy, okay? So our shading, if we'll go to shading, it's pretty much the close to what we had, right? But now we actually have a shading trackers on the terrain, so we probably should take terrain shading into account, right? So we have 1228. So now let's run the terrain shading. As you can see here, instead of 1228, we actually lost 1294, which is 0.7 percentages more, which might be significant for bigger projects, right? So, but again, as we know that this is not feasible solution because our trackers can be placed like that, so this number probably will not give us too much of an information. It's still some kind of educational guesses and stuff like that, but in order to make a better educational guess, let's try to simulate the real life situation. And so the real life situation is that if you want to place those trackers in this specific place, right, we probably will need to do cut fill. And so if we will do cut fill, we will probably do it with the real limitations from the manufacturer. So let's say 1 feet grading window, 0 net balance, and then the limitation along the axis, track axis, will be also, let's say 15%. So I'll run the cut and fill here. So what's gonna happen now? Our algorithm will basically change the terrain to make sure that your trackers installed correctly, okay? So, and basically it will affect our energy model, which we will need to go and double check, and also it will affect our cut and fill cost, because we will need to move dirt. Moving dirt expensive, so we will have some cost of the actual moving dirt. And this is where we step into this nice balancing act where we need to do the best trade-offs, right? So you see the terrain has changed. You can see it from that angle. Also, if I'll select tracker, make a cross section, you can also see that actually now it's nice and clean. And also if I choose this tracker and check its basically slope, let me go to the slope, position, slope. You see it's like 10%, which is basically less than 15 what we requested. So we find now all our trackers installed properly. We also can check, okay, how did it affect our energy? How did it affect our shading? So if we'll go back to our energy, to shading report, you will see that actually, okay, we actually have less shading here, right? And then that's fine. And even taking into account the terrain shading, we still have less shading. You see, we actually took shading from the terrain into account, but because we have some offset, it doesn't actually create any shadows on our trackers, so we fine here. Okay, so indeed it's actually closer to the flat layout, but it's not flat layout, right? So in the flat layout we had less shading than what we have here in real life. And shading, it's an energy loss. Energy loss is a revenue loss. So basically we need always to keep this in mind. Also, now we need to pay some money to actually make this installation, right? If we go here, you can see that we did 36,000 cubic yards cut and 36,000 cubic yards fill. Okay, so that's a lot of grading. So, and basically we did it for the rigid trackers, right? But what if we want to actually and before we do that, before we actually go to the next step, let me just show you the actual cut fill so you understand what's going on. So let me just ignore my area where basically nothing is happening from minus 0.5 to plus 0.5. Okay, so and let's make it just like this. Okay, so yeah, so basically this is what happened to this terrain. This is where we cut, this is where we fill, and this is how we installed our trackers, right? So let's go back to elevations, and now let's say we want to do another experiment. Now we want to do the same type of situation, but we want to use terrain following trackers, because we want to reduce the amount of cut and fill we need to do, right? Again, just to remind you, 36,000 cut, 36,000 fill, okay? So now I will use 1.5% slope change, and then let's say 7% cumulative slope change, okay? I will reset our terrain and I will rerun cut and fill. So what's gonna happen now is that we will consider those trackers as a terrain following trackers, which can go like a serpentine through on the terrain, so it kind of saves the amount of cut and fill we need to do. But also, what's important, it also affects energy, it also affects shading, which also needs to be taken into account. I mean, it's impressive. This is a proper engineering, and I love such trade-offs, and I love those solutions where you need to evaluate, you know, like what's going on and like what kind of where do we need to sacrifice in order to win more in a different places. So those evaluating and understanding those trade-offs are key point for actually producing the best designs. Okay, so look, we got a trackers now. You can probably see that they are already kind of go like serpentine. Let me just make sure that's indeed like this. You see, so the trackers now are terrain following. Let me make it like this, and I'll show you a bit more here. Okay, so like this. Cool. So as you see here, they are indeed terrain following, and we're supposed to have less cut fill. So let's check. So let me go here. Let me show the actual cut and fill. Okay, I mean, seems similar to what we had before, but what about volumes? So if we go to the properties, now we have 29, let's say 30,000. Instead of 72,000 for cut and fill, now we got around 60. So it's around 17% less cut and fill, right? So that's amazing. So indeed, terrain following trackers can save you some cut and fill. They're also more expensive, right? So let's say they're expensive, 15% more expensive, and then they save you some cut fill. It's a good place to actually to do some math and to understand what is the best solution. But also it's important to keep in mind that terrain following trackers affect your shading as well, right? As you can see here, we started to get more shading because we did less cut fill, so our terrain a bit more slopey, right? So basically this will start create some shades, and this is where we got some more shading, and this is where, again, same story, same balance, same understanding trade-off situations, right? Okay, that's basically what I wanted to emphasize, that actually flat layout is not exactly what's going on in real life. Trackers needs to be placed on the terrain because this is where they will be eventually built or installed, right? And so those kind of placements and those actions, they have their reactions. So it affects shading, it affects energy, it affects cost of cut fill, and basically analyzing all of that in a 3D with a proper level of accuracy for the terrain can help us to get, you know, like a better insights, can help us have better insights and better information for the best decisions, right? Let's have more fun. Okay, let's make a basin here. We will extract 1 million cubic yards, and then we will use that 1 million cubic yards to make our trackers kind of flatter, to flatten the terrain under arrays, okay? So again, it's more like a theoretical, nerdy, fun type of exercise, but I think it's funny, so let's do that, okay? So what I'm gonna do here, I will just go to my boundary and I create a boundary in here, okay? So now let's make it visible, okay, like this, perfect. So we have boundary. I go to our terrain and piles. Instead of equipment, I select this boundary, and then let's say I will just do 1%, just no limitations, and then minus 1 million cubic yards, okay? So I'll leave solar arrays as this because we don't have solar arrays in this boundary, so it doesn't matter. But let's run this analysis. So what's happening here is that we're literally excavating some dirt from this area, okay? And we try to make the bottom of this area literally flat. That's what we got. Let me go to our cut and fill, and let me do this. Look at this. It's a proper basin with a flat bottom. So we now have, if I'll go to the properties, you will see that we now have net balance minus 1 million. And now let's use this 1 million of dirt to make our arrays flat, okay? So in order to do that, I will choose my equipment. I will leave it as all equipment, and then instead of minus, I will put plus here basically, and then I'll make it. Let's not be so strict with 1%. Let's do 5%, and for the slope along axis, let's say 10%, and then let's actually use rigid trackers. So the trackers without undulated capabilities. Okay. So now let's run it. So what's expected here is that we will start getting this area a bit more flat, and we will start seeing the rigid trackers here. And again, the expected result is that we will start getting less shading and also less cut and fill. Again, not less cut fill. We have a lot of cut fill. We start getting less kind of slope changes on this area. Okay, here we go. Let's go into cut fill, apply some colors. You can see now they're literally quite flat, so 5. And basically, if we will go back and check our cut volume and fill volume, you can see that actually cut volume 1 million, and then fill volume is 1 million, and then we have net balance close to basically 0. So that's what we actually did. So we created a basin here, and we used this dirt to something, right? For some reason, it doesn't really matter. And this particular example might be a bit funny, but actually there are many real examples where people use basins and then they use dirt from those basins to make the terrain around more, let's say, better for installing trackers. Okay, so that's what we got. Let's go back to energy and let's see that actually now we have 12.15% shading, which is probably less than it was on the flat layout. So that's the type of exercises I want to go through with you. I hope it was interesting and fun. Thanks for your attention and have a great day.